Trigonometry is basically based on right angle triangle specifically. This thing we already know. Right angle triangle. What are the parts of right angle triangle? Hypotenuse and perpendicular, or the height and the base. All right. If I am moving towards this particular part, hypotenuse is always the longest side. Or more specifically, if we will say, it is the side which is just opposite to the 90 degree. If we can see from here, both the parts. Now, if I am talking about perpendicular and base, it is not fixed. Depending upon which angle question is asking, that is the thing. So if suppose, for an example, a question is talking about angle C. So whichever angle question is talking about, one thing is for sure, the angle will be between the hypotenuse and the base, always. So whatever angle question is saying, hypotenuse is fixed, other side will be the base always, or which we call it as the side adjacent to the angle C. All right. And side opposite is basically the height or the perpendicular. Whatever angle question is saying, one thing is for sure, that angle will be in between hypotenuse and the base. All right. And whatever side left will be the perpendicular always. So in terms of angle A, if we will see, always it will be forming between hypotenuse. So this will be the base and this will be for sure perpendicular. How many trigonometric ratios are there? If I am talking about hypotenuse, this is the base for angle A and this is the perpendicular. So first thing, if I'm writing the ratio for sine of angle A, since here angle A is given to us, can we see? All right. So if I'm talking about sine of angle A, do we know what is the concept for sine of angle A? It is always perpendicular by hypotenuse. If I'm seeing the shape and if I'm writing the sides, it will be BC over AC. And second part is cos of angle A. This particular is always base over hypotenuse, which is AB divided by AC. Third is the tan of angle A. Tan of angle A. This is always perpendicular over base. Formula, and the thing what we will write is BC over AB. These three things are very basic. Now, three more things are there. One fourth thing is cot, fifth thing is sec, and sixth thing is cosec. All right. Now, what is the difference? Cot of A, then comes sec of A, and then comes cosec of A. Now, very carefully, all right, if I am writing cot A is just opposite of tan. Cot A is just opposite of tan. So if you know tan is perpendicular by base, cot will be base over perpendicular. Sec is just opposite to cos. So if cos is B over H, sec A will be H over B. And in the same way, cosec is just opposite of sine. So if sine is P over H, it will be H over P. So systematically, if I want to write it in terms of side, it will become AB by BC. All right. Hypotenuse is AC, base is AB. And final thing, this will become hypotenuse is AC and perpendicular is BC. If you want a tabular form for sine, cos, and tan, how we can simplify and write it. And just opposite will go for cot, sec, and cosec. So perpendicular hypotenuse, base hypotenuse, and perpendicular base. So if you remember this particular part, first is sine, second is cos, third is tan, and then opposite goes cot, sec, and cosec. Remember three basic parts: sine, cos, and tan. Rest things you can do easily. So if I'm talking about sine, for an example, just now I have said it is just opposite of which particular part? Cosec A, correct? And same thing happens vice versa also. If cosec A is there, it is reciprocal of sine A. Same thing. Another thing is for cos A. It is opposite for
Sec A.
sec A. And same way, if I am writing, sec A will be the reciprocal for cos A. And finally, tan A is reciprocal for cot A, and cot A is reciprocal for tan A. One additional part is there. If I am talking about tan A separately, tan A can also be written as sine A over cos A. And cot A can also be written as cos A over sine A. One more way is there. Tan A can be represented as sine A divided by cos A, and cot A can be represented as cos A divided by sine A. Now, three ratios you have to remember for sure: tan, sine, cos, and table also. Table also you have to remember for three parts: sine, tan, and cos. Now, specific, if angle is given as theta, if suppose this is a right angle triangle and angle is given as theta, so for that the values are written for us. If you will see, sine 0 is 0, all right, sine 30 is 1 by 2, sine of 45, we are talking about angle like this. If sine 45 comes, what is the value? So value is 1 by root 2. This is what I am talking about. Sine of angle 60 is root 3 by 2 and 90 is 1. First, remember for sine. Remember for sine, 0 is 0, 30 is 1 by 2, 45 is 1 by root 2, 60 is root 3 by 2, and 90 is 1. Now, if you will focus carefully, for cos, just the opposite thing is happening. 0 is here, 1 by 2 is here. So basically, crisscross concept is going on for cos. If you remember for sine, you can flip the order and you can write it for cos also. Sine 45, both values are same, 1 by root 2. If you remember the values for sine theta, for cos theta, just flip it. Now, once you remember the value for sine theta, right? Sine theta is related to which particular angle also? Cosec also. Now, reciprocal. What is the meaning of reciprocal? If 0 is the value, so reciprocal means this is basically 0 over 1. So reciprocal will become what? 1 over 0. 1 over 0 is not defined. Sine theta value is 30-degree value is 1 by 2. Reciprocal means 1 by 2 reciprocal will become 2 by 1. That is the value for cosec 30. Same way, reciprocal for 45-degree is root 2 by 1. Same way, reciprocal for 60-degree will become 2 over root 3 and reciprocal for 1 over 1 will be 1. So if you remember for sine, automatically it will come for cos theta also, cos also, and which two parts are related with cos? Cos theta is related with sec theta. Same concept. Reciprocal for 1 over 1 is 1 only. Reciprocal for root 3 by 2 will be 2 by root 3. Reciprocal for 1 by root 2 is root 2 only. 1 by 2 is 2. And again, this is 0 over 1. So 1 over 0 is not defined. We cannot define anything that is dividing 0. So if you remember just the sine values, 4 values you can evaluate automatically. From sine theta, you can calculate cos theta. From sine theta, you can find cosec theta. If you identify cos theta, you can find the sec theta. But it will be better if you just remember the tan theta values. All right. No need for wasting time and again doing sine theta over cos theta. Tan theta and sine theta. Two values just you have to remember. Again, tan 0 is 0 only. 30 is 1 by root 3 and 45 is 1 root 3 and 90 degree is not defined. So once you remember the tan theta value, automatically cot theta and divided by 0 will be not defined. Reciprocal of 1 by root 3 will be root 3. 1 over 1 will be 1 only. Root 3 will be reciprocal 1 over root 3 and not defined. How it comes not defined? 1 over 0. So 0 over 1 will be 0 only. So cot of 90 will be 0. Just the reciprocal. So only two tables you have to remember. Sine theta table and the tan theta table. Now, final thing is the three trigonometric identities. Now, if you will see, angle A is talked about. So based on angle A or any angle possible, three basic identities are there. First identity is sine square A plus cos square A is equal to 1. First identity, most popular identity, we can say. First one. Square. Very carefully, square is, so if I'm writing once again for you guys, sine square A plus cos square A is equal to 1. Like this you will write. Second identity is between sec and tan. 1 plus tan square A is equal to sec square A. And the third one is between cot and cosec. Identity is saying cot square A plus 1 is equal to cosec square. The first question is saying find the trigonometric ratios of angle A. This is angle A. So based on angle A, we have to find the trigonometric ratios. So one thing is for sure, if angle A is set, opposite to 90 degrees always the hypotenuse, which means what? This part is considered as the hypotenuse. Now with angle, whatever angle is there, two sides are there, hypotenuse and one more side is the base, which means obviously this will be the perpendicular. So if tan A is given, systematically process we are considering. So since ratio is given, all right, tan A, all right, that is 4/3. We know that what is the concept for tan? Always it is perpendicular by base. It is always perpendicular by base from the ratio concept. Also, why we are adding here k value? Because it is a ratio. We don't know what is the factor. Least common factor is 4 and 3. That is why we have added with perpendicular length can be 4k and with base length can be 3k. All right. From 10, which more ratio we can identify directly using tan? Directly using tan. So basically cot A is just the reverse opposite of it. That will be 3/4. Now for getting sine and cos and sec and cosec, we need the hypotenuse. And in the right angle triangle, what we can apply? So if we are applying the Pythagoras theorem, what we can write it? AC squared is equal to AB squared plus BC squared. From here, we can write H squared is equal to AB squared is 3k the whole squared plus 4k the whole squared. If we simplify this, what will be the answer? H squared will be equal to 9k squared plus 16k squared, which will give us 25k squared. So hypotenuse will be root over 25k squared, which will give us 5k as the value. Now hypotenuse is coming as 5k using Pythagoras theorem. Now what we can find it out? Now we can find the sine of it. Basically perpendicular over hypotenuse, P by H. So with this will give us what? 4k divided by 5k. K and K will cancel out. So sine A value will be 4/5. If we have calculated sine A, directly using sine A, which more other ratio we can identify? So cosec A will be what directly? Just the reverse of it. Cos A concept is base over hypotenuse, which is 3k over 5k, which will give us 3/5. Sec A will be just reverse of the cos A. So answer for sec A will be 5/3.